All right, so this is the second part of the online lecture for the first week of IT 201. The previous video covered an introduction to Unity. I opened it up, I looked at all the window panels, I created a few different primitives, I moved them around, I showed you how to yourself move around the editor window or the scene window, how to mess around with the game camera. Now we're at a situation where we have our game scene saved. We did a few little tweaks. We just moved some objects around. And this video is now an introduction to scripting. So we're going to create a very small script at the end of it. And that's going to act as your activity. And as long as you can follow along, you can create the script, you can write out the code as I'm writing it, and it works, then you can consider that your activity is done, that your exercise is. If you get stuck at any point or have any questions, please come in for that additional lab time. So, I have Unity open. I have it in the exact same situation I had it when I left off in the other video. Now, I am going to go to the Assets folder. I'm in the Project window. Remember, this is basically just your file explorer. These are real files and folders that are on your computer, on your desktop. And if you notice, I have a folder called Scenes, and here's that sample scene. I'm going to go to root of assets. I'm going to right click and say create, and I'm going to create a folder. And just so you know, you can right click and get this create menu, or this create menu also exists right here, this button. So there's two ways to go about it. But I'm going to right click, create, I'm going to create a folder. I'm going to call it scripts. So we're starting to organize our assets. Again, assets are external files that we'll be creating that you will find on the asset store. But for this first project, we're keeping it very simple and just you're creating it. So we're going to go into the scripts folder and we're going to right click and say create a C# script. Again, you can just go create C# script here. Either way, create a C# script in the scripts folder. And I haven't named it yet. It created a file, and the name's kind of cut off. It says new behavior script, but it's in blue. It's still editable. Now is the time to name it, and I'm going to go into, it changes like a value in the file. So if you name it later, you're going to have to change the file, then you open it up and you have to change this other value in it. So right now, while it's open, you can almost kill two birds with one stone by just naming the file. So I'm going to call it unit click. So notice I called it capital U, unit, capital C, click. So these are two words. They're connected together. There's no spaces, hyphens, dashes, or anything. This is called Camel Case. All right, and for files, we start with a capital letter and no spaces. It can lead to a lot of issues. So we use Camel Case in programming, and here it's going to be unit click. Capital U, capital C, and the uppercase letters let you know when a new word is formed, and that's why it's called Camel Case, the ups and downs that it forms. So if I press the Enter key, the script gets created. This is what it looks like when an asset is clicked on. And over in the inspector, we notice that we get some details. The code of it is actually shown. But this is not where we edit the code. As the inspector, it just shows it the information of an asset. In this case, it's just showing the text within the file. So if I click off the file, this is what an asset or a file looks like when it's not selected, and this is what it looks like when it's selected. Notice down here, it shows our file path or our project path. We're in assets, scripts, and then here's the name of the script, .cs for a C# script. And if I right click and say show and explore, I'll move this over. Notice that we're in D, program, Unity projects, IT 201 project, and then we're in our assets folder, and I can open up the scripts folder. And here's that unit click.cs, And as I hover over it, it says it's a C# file. It also says it in a type over here. Now notice that there's this meta file. So every asset, every file that's going to be in your project, the game engine or Unity actually monitors it, and it has additional information that it adds to it. And then this meta file has that additional information, and it's also for Unity to know that this file is a part of this package, this project. So don't mess around with these meta files, don't change them, don't delete them. Just know that when you create assets, that they are real files, they'll be created, and this meta file comes along, gets created with it. So if I jump up to assets level, you see all I have in assets are 2 folders and their associated meta files. And then as I jump down to scripts, we have 1 file, 1 CS file with its associated meta file. So as I go back into Unity, we now have this 1 script, and here's some information about it. So all I'm going to do is double click on it. You see it says opening Visual Studio, and it's going to go through the process of opening up Visual Studio, and this is what it looks like. So it's dark. That's the default for usually for programming environments. It helps with the eyes. In fact, Unity actually has a dark version, but you have to pay for it. But in any case, this is what Visual Studio looks like. Notice how up here I'm logged in with my Microsoft account. I don't need to be logged in, but there might be a window that might pop up at first and say, you know, welcome to Visual Studio Community Edition, and would you like to log in? And then it'll say like, no, you can either skip the login or do it. Either case, you should get to this. This is what Visual Studio looks like. It says I'm basically connected to my Unity project, which is IT201 project. We can see it here and here. Basically, this is our coding environment, which is connected to our Unity editor, and they are 2 separate programs. And within this program, we have a tab open. All right, over here, we're not really going to get into the solution space and what these project files mean. All you can recognize is that we're in a solution. The solution is just going to be a programming project, and the solution is called IT201 project. That's about all you really need to know about these parts. We'll cover more later, but just know I have a C# script open. It's opened as a tab, and there's lines of text. Each line has a number associated with it. Notice that different text is colored differently. You can notice that we're in a C# file. Up here, the file is called UnitClick, and the method that we're currently in is the start method, which is right here. So let's just go through this script from top to bottom real quick. So we have some using statements up here. Notice how we can condense them. These are going to be super useful to if a script gets too big, that you can expand, minimize, and maximize it to look into it. But the using statements are separate than this section of code right here, which is our class. Notice how the class is our main part of our code. It's also called whatever the file is. So that's that kind of killing 2 birds with 1 stone I was talking about, that if you name your file right away, it'll name the class in it. So if you end up creating a file and it's too late, and you get that default name, that new behavior, and you rename it, you might get an error because now you named the file name something, but the class is named something else. So you'd have to go in here and change the class so that it matches the file name, and if you save it, you'll get rid of that error. And we'll get into what errors look like in a minute. But we have a class, and this class will get instantiated. Instances of it will be created on our game objects. Think of this as like a blueprint of an object that will be created. We are creating the blueprint, the class for what this object will be. So a class is like a blueprint. When you use this script, which is usually just 1 class, and you place it on a game object, that class, that script, gets run on that game object. An instance of it gets created, which we call as an object. and it does whatever it is that we state within it. And so it can do anything that you need it to do, and it's very variable. But for now, just say it's a class. We have a public class, meaning we can access it. We'll get into accessors later. The name, the semicolon, means that we're extending it from a mono behavior class. As I hover over it, here's one of the features of Visual Studio. It says that this mono behavior is a class that's coming from the Unity engine. And then we even have a little description of it called mono behavior is the base class from which every Unity script derives. So, a few things are connected to this. One, our class, UnitClick, is inheriting from mono behavior. All you need to know about that is that we're able to use it in Unity. And you'll see in a moment as I create this script, you'll be able to connect it to a game object, and it actually functions when we click play. And all that functionality, the reason that it can exist and do that is because it's inheriting behavior. It's inheriting code from this mono behavior class, which is a piece of code that's already created. It's external and we're referencing it. And how are we referencing it? And first off, you don't even need to know any details about it. It gives you all this features, all this functionality. Don't worry about it. But it is coming from Unity Engine. So that class, Unity Engine dot mono behavior, it is a part of this larger class called Unity Engine. It's a part of this larger library, I should say, of code. Now, where are we referencing it? Where are we getting all this external code from? Well, up here in these using statements. So we're saying I'm using the Unity Engine library of code, or I'm referencing the Unity Engine namespace, which is more code that's coming along for the ride from Unity that you don't have to access, you don't need to know about. They did a lot of the heavy lifting for you. It just says, hey, I'm using this chunk of code, it's called Unity Engine, and that allows me to reference other stuff. So my class, my script, is going to be inheriting from this mono behavior class, which is coming from using Unity Engine. So if I deleted this line, it would give me an error because it would say, well, what's happening? Why aren't you, who's this mono behavior? So as I did a double / this line turned green, and that means that I commented it out. You can also see there's other lines that are green. These are comments. They're only for people to read. They're not computer code that gets compiled at runtime and gets executed during our game. So as I comment out this line of code, it just becomes text that only people can read. And commenting out is this / Now when I did that, notice how the whole color of this line changed. This using Unity went from this to green, and mono behavior, this reference, now has this red underline. That red underline is stating that there's an error, an issue, something's wrong, we should look at it. So also notice that there's this little red dot there. So as I click on this line, notice how this little white line goes to where the red dot is where the error is. So if I click down here, here's the white line. This is where we are in our section of code. And as I click back, here's the red line. And this yellow means that you just did a change. So notice that the file has a little asterisk. And if you do a Control S or file save, just like everything else, it would save the file. I'm not ready to save the file yet because that leads me back to talking about Unity. So let me just continue on here to click here and hover over and get some tips from Visual Studio to tell me what's going on. So it says the type or namespace name mono behavior could not be found. Are you missing a using directive or an assembly reference? So it's actually kind of smart. It's trying to figure out why there's errors. And from the context of the situation, it says, oh, you might be missing a using directive, which is what I commented out. So I'll undo the comment. Notice how the red dot on the bar over here goes away. Notice how this changes color back to this light blue, and notice that the error, the underlying red, goes away, and we're back to a script that does not have errors in it. So notice how this using statement is a stronger shade. It's brighter, it's more white than these using statements. These using statements are collections. If you've had your Java, your Python class, these are arrays, and strings, and data structures that we're not using yet. So, but they commonly are used a lot. So these using statements come along when you first create a script. It's just that you're not actually referencing these libraries of code yet. I'm not talking about arrays or any other data structures like that. So this one is being referenced actively. This mono behavior is here. So that's using statements. That's our initial statement of a class, which is inheriting from mono behavior. And then we have these curly brackets. And to make things a little bit easier to understand with these curly brackets, I'm going to press the Enter key, move this curly bracket down, and notice how my cursor is on it, and it's got like highlighted dark blue, and down here, this other curly bracket is highlighted as a dark blue. So that means these two are connected. In fact, we have this one is the open one. This one down here is the closed one. And as I click on it, it tells me what it's connected to. In this case, it's connected to the class, the overarching statement. And then if I click up here, it's showing that this curly bracket is connected to it. So if I, for a moment, go to the start method, and I haven't talked about methods yet, but if I click on this bracket, notice how it highlights this one. And as I hover over it, the pop-up stating what it's relating to is it's stating to the start method, not the overarching class. So you have to use these curly brackets start and end when you're declaring a class, when you're declaring a method, and we're even going to use them later in our if statements and our loops. So basically a section of code that all connects to each other. In this case, all this code is part of our class. So we have to start it, we have to declare it and say here's where it begins and here is where it ends. And the same with this method, which I'm just going to move these brackets down. This is a common, when you first start your script, it's common to press the Enter key and move these starting brackets down by pressing the Enter key, because then it's a little bit easier to read. It's like, oh, okay, here's the start method. It starts here and it ends here for this method. It's a little easier to read. So we have a class right now that contains two methods. These two methods are empty, and that's it. So it's basically a starter script. It's completely empty. A start method and an update method, which are methods that are coming from this mono behavior that are run in the game engine. So methods are also called functions. There's sections of code that you can call from within a script or another script, and it's a good way to like reuse sections of code instead of writing it over and over again. You might put it into a function or a method and then call that method over and over again as you need it. So these are kind of special methods, and the start method runs once at once when this game object is first created. It first starts up. Usually most of these game objects start up when the game first starts up. Not always, because later on we'll get into actually instantiating game objects later on during runtime, actually dynamically spawning game objects that have these scripts on it. But this game object exists in our game scene already. It will become alive, or it will start up right when I click play. And so this void start method basically runs once, and it runs right when I click play, or if we build our app, it runs right when that app starts up. The update method runs every as quickly as it can. It's a loop. It continually runs through its code over and over and over again. And this is how like your monitors are refreshed, say every 60 frames a second, or 60 times a second, or 75 times a second. That's kind of a loop of code. It goes through, the monitor goes through and updates all of its pixels, and 60, 75 times a second. You don't even notice it, and it's so quick. It feels like animation. It feels like it's alive. That that update of that monitor is very similar to like an update loop. So this code is going to be run all the time. It's very useful when you're checking for user input, or when you want to just constantly put stuff moving, or other interactivity or checks that we want to do 30 to 40 to 50 times a second. So it's a variable number that this update loop will run in a second. It depends on how strong your computer is. It depends on what other programs on your operating system are taking up processing power. It depends on how intense this application is, how many times it can actually get to this object and run this update loop. But basically know that like this is where we're going to check for user input. Basically around 40, 50, 60 times a second, it's going to say, is a user pressing a key? Is a user pressing a key? Is a user pressing a key? And if so, it's going to do something. And this is why the painting program you saw, it was just painting objects as I was clicking down, because it's checking that many times a second if I'm actually pressing any user input, any keys. So these two methods are very important. They're very useful. They're very specific to Unity. And sometimes you use them and sometimes you don't. I wanted to introduce them. And actually, they're a good way for me to introduce a debug statement, a first way for us to connect back to Unity. So, all I did so far was move these brackets so that we can see our start and end of our methods, our class. Oh, some features of the method. So we have a void, and then the name of the method, and then these parentheses. And then within these curly brackets is wherever the core of the code that gets run by the method. So a void means it's returning nothing. It's returning void. So we'll get into return statements later. Just know that a method that is of type void will just run code, and it's not expected to return any variables, any values that like another method or something else can process on. So it just runs a bunch of lines of code. Now, when there is no private or public in front of a method, a variable, or a class, it's just defaulted to private. So I just wrote in private here, just to know that whenever you see a method call and it doesn't say public or private, by default, it's going to fall to private, or it's going to set to private. So I'm going to type it out so that you explicitly can see it and understand what this is. So this private means only the class, only this script can call this method, or can, and later on when we get into variables, can access this variable. So that means that only this class can call start or update. No other script can reach in and actually call that method on that class, or that instance of that class that will be running on some game object as your app is played. So understanding private and public accessors is important. Just know that this instance of its class can only call these methods, and it's good coding practice to keep most things private, to know only this script can call these or can change these variables. You only be very aware when you make stuff public, because it can get a mess that other scripts are calling other parts of other scripts. So these parentheses are empty, meaning that there's no information, no values, no variables that will be pulled in to this method. So if there were some ints or some floats, we might be able to reference them in this method, and sometimes that's very useful. In this situation, just know that these parentheses are empty. So this means this method runs, and it runs without any additional information being placed into it. So now that we've talked about all the parts of a method, I'm going to introduce one statement And as I'm typing out debug, notice how I'm getting these lists of objects or classes or variables that they think I might be referencing. And I want to actually reference debug. As I keep typing it out more, there's less options that actually have these letters in it, and so this list gets shorter. So it's really helpful when the list, you can actually, let me open up a bit and say, oh, there's this big list of things I can reference that start with DE, and I want this debug. And as I hover over it, notice it gives me some information. It says it's from the Unity Engine class, and it's a class containing, it's from the Unity Engine library. It's a class within the library, and it's containing methods to ease debugging while development. So we're going to start off with this debug method call, or this eventually we'll call method in this class, because it's going to be very useful for us right now. So I can either type out debug, or I can find it in my list and just press the enter key. Either way, it helps you so you don't have to type stuff all the way out. Now it says there's an error right now because you can't just like list a class, and that's not my end result here. I'm going to use the dot operator, and the dot operator allows me to access either variables or methods from a class. And in this case, I'm looking at everything that's available to me within the debug class. So, debug dot, I can look around down in here, and actually what I wish to use is the debug.log, which is going to allow me to print a message to the Unity console. So again, you can type it out, or you can find it in the list. In any case, I'm going to press the enter key. So now I've called a class that was already generated, somebody already wrote it up in the Unity Engine library. Now I'm going to reference a method in it called log. It's still showing me an error because a method call needs to have parentheses. And as I place that one parenthesis, which is shift 9, it actually auto-completed the ending parenthesis. So now I have debug.log with an open and a closed parenthesis, and actually now I have a pop-up saying, okay, how do you use this method call? Well, you can place an object in it, or you can place an object in a context in it. Okay, let me go back to the simpler one. This logs a message to the console, but you got to place a message into it. So an object is a very abstract class, I'll say. Almost anything you put in here can be converted to an object. So I'm just going to put a string in because this is a very common situation. So a string is just a line of characters that is just text that we can, that's useful for people to read. So you start with the double quote, shift, and it's a quote key, and it auto completes to give me 2 quotes. And I'm just going to write, yeah, it's cliche to write that hello world over again. So I'm just going to say, this is the Unity console. All right. This is my message I'm going to send to the Unity console. I'm just going to move my cursor over to this ending parenthesis. And you see how there's still this red arrow underline, this red error underline here. So to actually end a command, end a line of code, you use a semicolon. And so once I enter that semicolon, my line of code is actually complete. It doesn't find any errors with it, and this is where I'm going to actually save it. So watch, there's all this yellow marking, and these, and then here in our little little graphical vision of our script, to know that there's changes, and I have an asterisk here. I'm just kind of press Control S, and see everything turns green. The asterisk is gone, and I'm going to click back to Unity. I'm going to move down here. Notice this little gear thing. That means it's actually processing the script. So Visual Studio checked everything was great with our script, our code. We saved it out. I'm going to click on my game object. This is my script. If I click on it first, here, look, notice how it's changed. I have my debug statement, everything. Click on sphere. You drag the script on the inspector, add it to my object. Now I'm going to remove it. You can also drag it right into the hierarchy. Notice how it got assigned here. I'm going to remove it again. And you can just drag it right onto the 3D, the visualized version of it in the scene view. Either way, those three different ways, this script is now connected to this sphere, this game object. This is one of multiple components. These are called components, parts, segmented modular parts of a game object. Each one is actually a script. It's just been built from the Unity team, and so it's got all these nice little icons and user interface. And this is my script that I just created, and you can see it's a little C# script on it. So I'm going to click over to the console here and click play. And when I clicked play, we're in active play mode right now. The game session is live. It's testing out the app. It's just the app's not really doing much right now. This is what it looks like from the player's view. But we saw in the console here, we have a timestamp, and my little message was printed out. And if I click on it, it said, this is the message. This is the Unity console. And it was some type of debug log object that's printing this out to the console. And who did it? Well, unit click init start method. And this is the location of the script in our project, asset scripts here, and line 11. So you get a lot of information. If I go back to it, here it is, actually line 11. This is what printed it out. So you get a lot of information printed out. And notice that it has this exclamation mark here. Notice over here, we have these little filters, and if I click off there, we don't see it. It's still been, this is our little line down here, it shows it. But you can like filter out information. So these are warnings, errors, and notifications. And notifications are really useful to like know what's going on in the game, give you some messages to know if things are working or not. So I'm gonna unclick play, and you can clear out, or notice how I have clear on play clicked, which means when you click play again, it'll like clear out your console so that you know that whatever's in the console is related to that direct play session. So I'm gonna actually replace it, say this is the start method, and I'm just gonna copy this whole line. I'm gonna put it in the update loop and say this is the update method. I'm gonna save it. So again, start method plays once right when the game object comes live or the script actually runs, and then update runs as many times as it can per second. So I'm going to let that compile. Down here you can see it's compiling. We're done. I don't need to connect the script again because I just did it. Now look here in the console, and so we're getting this flashing, and we're seeing that timestamp is changing. So and we're seeing that our numbers of notifications are growing. So this is actually the update loop running and running. This is the update loop. So if I collapse, this will give you all the unique notifications, and this shows how many times each unique notification has been called. So we have a one instance of this, the start method, which makes sense. It was called once, and when the start method was called when everything ran. Now we have, this is the update method. See how it's still running. We are close to 2,600 calls of the update method so far, and it gives a timestamp of the most recent one. All right, so if I stopped and I slide all the way up, we have, this is the start method, this is the update, update, update forever, right? And then you see we have over like 1,000 messages. So I'll clear it out. So that is the debug log, and now you're seeing the connection between Visual Studio and Unity. And I showed you some comments. Now I'm going to show you a new comment, /*, and */ if you want to comment out a whole section of code without having to go through and do // on each line. Cool. Now we're almost done here. Now I am going to just create one method. So notice how the class is still active, its brackets are still active, just this part is just commented out. So now I'm going to create a private void on mouse down. Alright? On mouse down is called when the user has pressed the mouse button while over some type of collider or element. Great. So this is A little cryptic, and it's doing a lot for us. Most of our code we are going to get a little bit deeper into. The reason I'm using this method is it allows us to read in user input without having to introduce more concepts. Later on, we'll use the update loop to introduce user input. For now, I'm going to do a debug log. And I'm going to say name. So the name of this game object. Notice how name, it's kind of shorthand of saying whatever the name of this object is. Plus, we call it concatenation, meaning we're going to add this to that and then put it in the log. So was clicked, only world position returned is, and I'm going to concatenate it again with transform dot position. So on mouse button down, when I click, we're going to get a debug statement that says whatever I'm clicking on plus was clicked, only world position returned is, and then take the transform of whatever I'm clicking on, give in its position. So basically we're taking three pieces of information, whether the name I'm clicking on, put the string here, and then whatever its position of this object I'm clicking on. So transform.position. So as I click over and I let the script compile, this sphere, remember this transform here and this position part of it, X, Y, and Z. Remember I was moving stuff around, you saw the information on it change, the numbers change. If I click play, we're going to grab that. So I'm in game view and I'm going to click on the sphere, and it said sphere was clicked, only world position return is 0, 0, 0. So actually I'm going to move this sphere a little bit. I'm going to click it again. The sphere was clicked, the world position returned is 0, 0, negative 2. And look up here, 0, 0, negative 1.96, it's rounding up. But it's actually taking the name of this object, which is here, sphere, saying we clicked on it. It's got this collider on it. We'll get into this later. That's why this on mouse down can read it. And it's returning the actual position information. So we're actually gathering information from this object. So what I can do is my sphere 01, duplicate it, move them up, Control D, and call it my sphere 2. And I'm just going to put them in different positions so that I can still see them in the game world. Each of them has that unit click script. Click play, click on this one. My sphere 1 was clicked, here its position, you can see it's right. Now click on this one so you can see its position, click here. My sphere 2 is clicked, and the world position is this, which is this one. So now we're gathering information from an object we're clicking on in the world. Not only do we get the name of the game object, which you can see in the hierarchy, here in the inspector, but we're getting its position information. And we're returning it in a debug statement. So this is what the script looks like. And so we're actually starting to call other components, other game objects that we're clicking on with this on mouse down. So if you have any issues with this, not able to compile the script, or have questions, please come into lab time. Thank you.